So can somebody tell me why we need robustness? So what was the big picture for neural networks and deep learning and machine learning in general? You want to end up with a source code that you're going to put in production. For instance, you want to come up with an image classifier that you want to put into production. And exactly, you want your models to be robust. You want the algorithm to be robust in the face of small perturbations. Because once you take your algorithm, put it into production, you don't want an adversary to mess up with your algorithm and cause trouble. So that's the big picture. Why you want your model and algorithm to be robust. But it turns out that these neural networks are actually not robust. You end up with an image classifier, and they're going to end up having blind spots. And blind spots in this form. You have an image, you perturb it a little bit, it's going to give you a very similar image to a human eye. But then a human is going to classify that correctly. For instance, it's going to classify this dog as a dog. But then all of these cases, all of these columns, to the eye of the algorithm are getting classified as an ostrich. And somebody might say this is only for this particular data set and for this particular neural network architecture. And that's not true. These adversarial examples are going to end up being generalizable. We can take this example, show it to a different neural network that is trained by a different data, and then that neural network is still going to confuse this with a high probability. Any questions about this? So this was an assignment for you to watch. So what we are optimizing over here are these perturbations. So these are not random perturbations. Some adversary came up with good perturbations for that particular image. There is a question in the chat. Would it ever make sense to look at reverse blind spots? Like, what is the smallest perturbation you need to get wrong classifications to become correct? But in that case, you're actually not an adversary, you're actually a collaborator. So you're actually helping the classifier. Because what is the end goal of a classifier? Is to classify correctly. And you're helping it classify correctly. So you're helping it as a teacher to remove its mistakes. And if the idea is to somehow help us, then yes, if you don't want to think of them as blind spots, but actually something that is helping your classifier, then yes, that could be a good idea. You're saying that I have an image, it is getting classified wrong, and I can correct the mistakes of my classifier on that particular image by perturbing it a little bit. That's a good idea. I like it. But this has nothing to do with robustness and adversarial attacks. Okay? Any other questions, ideas? Why is this a serious problem? This could become very serious. Let's say you are driving a car, you are playing a music, and your car is actually a self-driving car. You are playing the music, and then some adversary is going to change your music slightly, like add a little bit of perturbation to it. To the human ear, that's going to sound like a usual music. There is nothing wrong with that. But then to the ears of the self-driving car, it could be that accelerate or cross the red light. That could be what your car is hearing. It could hear some instructions, and that could lead to accidents and serious problems. So now you're seeing the big picture. It's not only about classification. Even the classification is very important. For instance, a red light could be classified as a green light, and imagine the consequences. That's why you want your neural networks to be robust, because these are safety issues and security issues.